been to one of my classes, um, I welcome questions. You can unmute yourself or post your question in the meeting chat, and I'll try to pay attention to that as we go. That way, especially with things like this, if you're feeling confused, we just need to slow down and make sure that all those questions are answered before we move forward. A lot of this kind of builds on the knowledge that we're sharing as we move through it. So please don't hesitate to send me a message if you're not comfortable doing that publicly. You can send me a direct message in the meeting chat, and I'll not embarrass you or anything like that, but just make sure that I get your question answered as well. Okay. So, skewed distributions, as if understanding the bell curve were not hard enough. It doesn't have to be difficult, but what do we do when the bell curve is not bell-shaped, right? If it's skewed, what does that mean and how do we understand it? So that's kind of what we're going to be focusing on today. If you've attended my bell curve class, the first part of this may sound familiar because I think it's good to have a foundation. So basically, when we are looking at the bell curve, we need to understand that it's a type of graph that's used to visualize the way that data is distributed. A skewed distribution is just the same. It's just distributed less evenly. So with a normal bell curve, the that's depicted has a central average indicated by the peak of the curve, and then low and high extremes indicated by the tails on either side of the curve. Okay, we're going to see how a skewed distribution changes that. Okay, so in order to better understand what this means as far as like the data being depicted, suppose you have some data from a test. Each one of these little squares represents one test taker's score. And you'll see why I'm just using colors here in just a minute. But here I've got 100 squares of varying colors. It's not organized at all. There's not a whole lot that can be done with this information. At best, we could count all of these squares and know that there were 100 people that took this test, okay? It needs to be organized. And so what we're going to do is group the like scores, the similar scores together. And when we do that, these are the same squares, just organized in rows based on the color, okay? And so you can see that some colors, which represent test scores, had more people that scored that, and some, like the gray square, had less people that scored that. Okay. But what if we wanted to organize it further based on what score each color represented? And so now we could say that this gray square represents a score of 69. So one person scored 69. This purple, 37, we could say that 5 people scored a 37. Okay. So we can organize those scores in order, and now we can see the way that they're distributed more easily. And this is how we begin to arrive at a bell curve. You'll see earlier I mentioned the gray score was 69. That was the highest score on this test. 37 had 5, so it falls over here. And so if we create a line drawing using the total number of each score, we can kind of see how the bell curve is formed using that data. Okay, I'm going to pause here. Does this make sense so far?
Yes.
Okay, stop me if it doesn't, or if you have questions. Obviously, the numbers down here on the bottom for the scores are going to vary depending on the test and the assessment. But if we wanted to plot this on the bell curve chart that you're more familiar with, it might look something more like this, right? You can see we've got the same colors. I had to widen them a little bit in order for it to fit the actual curve, but that's basically how we arrive at a bell curve, okay? So now we're going to transition into talking more about what happens with skewed distributions, okay? On a normal bell curve distribution, we have symmetry. Symmetry means it's kind of a mirror image. If we were to draw a line right down the middle and fold it in half, both halves would be mirrored one another. Okay, so right here we've got one person that scored 45 and one person that scored 185. two that scored 55, two that scored 175. There's symmetry, okay? And I already showed you this. On a normal bell curve, we need to understand that there's this empirical rule related to 65% of the scores falling between one standard deviation plus or minus. 95% of the scores fall between -2 and +2 standard deviations. And then 99.7 of all of the scores fall between -3 and +3 standard deviations. Okay. That's what happens when we have a symmetrical data scattering. Okay. There's symmetry. I'm going to come back to this in a minute, but in a normal distribution, a bell curve, the mean average is the exact same as the median average, is the exact same as the mode average. We're going to unpack that in a little bit. The reason that a normal distribution is helpful is that we can come up with predictable probability estimates, right? We can, if there's a normal distribution, we can predict what might happen on future versions of these tests, right? And that's why this is helpful in statistics, is it helps us to be able to understand what can we expect if more people take this test in future versions, okay? And there's just some different tests that we can run on a normal bell curve, like t-tests, and we're not going to go into all of those today, okay? However, on a negatively skewed test, we don't have symmetry, okay? You can see down here, we've got the same scores, but now they're not symmetrical. Our highest score of a 10 is over here on the far right side. A key phrase that we want to remember with skewed distributions is the tail tells the tale, okay? The tail is the long end of the curve. And so here we have a long end of the curve over here on the left side. The left is going to be negative and right is going to be positive. So if it was right here, this would be a positively skewed test distribution. This is negatively skewed, okay? So how do we know how skewed it is? Well, we've got a formula for that. And it's good to know the formula. You're not going to have to do complex calculations on the test. But the formula is that our mean average minus our median average equals the degree of skew. Okay. Some of you may be feeling, oh my goodness, I've got to do math here. We're going to unpack what these averages mean, because this is something that's very testable. Okay. So when we're looking at averages, there's three types that we're looking at: the mode, median, and mean. The mode average is the number that shows up the most. The median average is the middle number when all of the numbers are in order. And the mean average, this is what we usually talk about when we say average. This is, you know, if it says the average, this is probably what it's talking about. And to do this, we add up all of the numbers and then divide by how many there are. We're going to do some practices here, okay? So for this score set, what is the mode? The number that shows up the most. What do you think? What number is showing up the most here? You can answer in the chat if you want.
115.
Good, 115, right? There's the number of respondents who achieved that score is 10, right? We could count up the boxes, but we can just look visually and see that 115 has the most. Mode equals most, okay? So yes, 115 is a score we're looking for, okay? What about on this one? This is a skewed distribution that's negatively skewed. What is the mode of this score set? The number that shows up the most?
145.
Right. Yeah, we can look and see visually that 145. Also, I've got it numbered down here at the bottom. So there's 10 people that scored 145. So 145 is the mode of this score set. How about this one?
75.
Good, 75, right? It's easy to tell when the data is lined up like this and it's all organized what the mode is, okay? It may not be that way, or you're not going to have pictures on the NCE. You might have a list of numbers and you have to look and see how many numbers how many 75s there were in that list. Okay, so just know that whichever number is most occurring, that's going to be the mode of that set. Okay. So what about the median? What is the median of this score set? The middle number when all of the numbers are in the order.
Would that be the 115 as well?
Yeah, that'd be 115. Okay, so you can see here this red bar down at the bottom, like we've got all of the numbers in order, and we're going to try to find the middle number, right? Which is 115. We're coming in 10 from each side. And that gives us, well, not 10 from each side. 1, 2, 3, 4, 5, 6, 7, 8, right? The 8 from each side is the middle number. That's kind of what we have to do. When we get them all in order, we start with the outer and the first and the last, and then we move in, we move in, we move in, we move in until we find the very middle, and that's 115. Okay. What about this one? What's the median of this score set? I promise I'm not trying to trick you.
Is it 115?
Yeah, it's 115 too, right? Even though we've got a skewed distribution now instead of a normal distribution, because we've lined them all up, 115 is still in the middle, even though there's more that scored 145, because 115 is in the middle, that's still the median. Okay. What about this one?
Is it still
So
115?
115?
It's still
115.
it's still
Yeah.
115. Okay.
Yeah.
Okay. I'm not trying to trick you, just to reinforce that no matter whether it's negatively skewed or positively skewed, that it's
Mhm.
possible that the median might still stay the same if we have the same numbers. Okay. All right,
Mhm.
let's do one that's a little bit different now. What is the median of this score set? We've got different set of numbers here. Which one's in the middle?
115.
It's still
115.
115, right? Even though we've got such a wide variety, right? We've got a 999 as the top score and 23 as the bottom score. It doesn't matter how wide the range is either. Whatever is in the middle of all the scores, we're not taking the range and dividing it in half to find the median. We're just lining up the scores, and whichever one of those scores is in the middle, that's what the median is. Okay. Okay, how about this one? That's going to be hard to find out, isn't it?
841.
Okay, why do you say that? Because right now that's the one that's in the middle, but what's wrong with this data set?
Oh, I didn't look at the set.
Yeah, we got to look at the set. What's wrong with this data set? Why can't we find the middle like this very easily?
Oh, it's not in order.
It's not in order. Yes, very good. Yeah,
Oh, I'm
so
just talking. I didn't realize I was back on mute.
yeah. So we've got to pay really close attention with things like this, right? So when we
Mhm.
put these in order, we find that the middle number is 501, right? Our very lowest number is 0.7, right? Two people scored 0.7. One person scored 7,845. So when we line them all up and put them in order, we're still trying to find the one that's in the middle. And that would be
So,
501. Does that make
Josh,
sense?
I have a question
Sure.
about this because
Please.
I'm trying to put it in my mind. So even if you have it in order and you're trying to eyeball it, like for instance, the mean, you know that the average, then you're gonna times it by whatever it's on there. How would you eyeball the median and know that's 501?
Right.
Like for me, I'm trying to eyeball this and figure out where did you get
Okay.
501 from?
So the first thing that we have to do to find the median is we have to put the numbers in order. Okay. So that's the very first thing is if the numbers are not in order, we have to put them in order from our lowest number all the way to our highest number. Hopefully, you're not going to be given a list of numbers that's crazy long, but to eyeball it, we like I said earlier, what we have to do is start with the first and the last, and then we have to incrementally move in to the very middle. The other way we could do it is we could add like how many total scores do we have? So on this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 scores. So if we did half of 15, that would be 7.5, which we're not going to have a 7.5 score. So that would be the eighth score, which is right here in the middle. That would mean there's 7 on each side of that middle score. So eyeballing the median is a bit of a challenge. It's easy if we have an odd number of scores to know that there's going to be one score in the middle. If there's an even number of scores, then we have to take the 2 middle scores and then find the mean of those. That's kind of a separate deal, but okay. So eyeballing the median is a matter of looking and moving in from the outsides all the way to find the middle score. Okay, great question. Okay, so what about the mean? How do we find the mean of this score set, right? This is the average. We're going to add up all the numbers and then divide by how many there are. That's going to be hard to do just off the top of our head, right? Because there's a lot of scores. We can look at this and know what the mean is because on a normal distribution, the mean is always in the middle. On a bell curve, the mean score is always going to be in the middle. But if we wanted to add up all the scores, this is what we have to do, right? There's one 45 score, there's two 55s, there's three 65s, four 75s, right? So that's what we're having to do is add up all of those scores, and that would give us 8,970. You're not going to have to do this on the NCE, okay? Not with this many, okay? So once we've added them up, then we have to divide by the total number of scores. So that's the total number of scores. So we'd have to know exactly how many people took this test. There's 78 red squares on here. Okay, there's no way to calculate this in your head. You're not going to be asked to do things like this on the NCE. But if we're just understanding how to find the mean is also 115. 8,970 divided by 78 is 115. So the mean is 115 as well. Okay. I'm going to pause there. Questions about mean, median, and mode, and how we find those averages?
No.
Yeah, can you go over to me one more time, please?
Sure. Let's do it like this. So if we're trying to find the mean score, each one of these boxes, these little squares, represents a score. So we have to add up all of the scores from all of the participants. So we're going to add 175. We're going to add 55 and 55. We're going to add 65 plus 65 plus 65 plus 75 plus 75 plus 75 plus 75. So we're going to add all of these together. That's what's shown here. And so our total, once we add all of the scores from all of the participants, is going to be 8,970. And then we have to divide that by the total number of scores, which basically means if everybody got the same score based on the total, like there were only 8,970 points awarded, and they were distributed evenly to all 78 participants, we'd have 115 as the average score for each participant. Okay. It'd be easy if everybody scored the same to know what the mean score was. It'd be the same. If 5 people each scored 5 on an exam, then the mean would be 5, right? 5 scores of 5 is 25 total points divided by 5 test takers means that each one gets 5 points. But suppose one person gets 5, 2 people get 4, and 2 people get 3. Well, now we got to figure out what the average is by adding all of those scores. 2 3s plus 2 4s plus 1 5. 3 plus 4 is 7, plus 5 is 12, plus another 7 is 19. So we'd have to figure it out that way. Okay. You may have noticed that in all of the normal distribution, the mean, the median, and the mode were all the same. Okay. And that's how we know it's a normal distribution on a bell curve, is that the mean score, when we add up all the scores and divide up by the number of scores, that's 115 on this one. The median, meaning the middle score, was 115. And the mode score, the one that had the most, was also 115. And that on any normal distributed bell curve, that's going to be the case, that the mean, the median, and the mode is the same. Questions on that?
No.
Okay. So now we get to understand what's different about a negatively skewed or a positively skewed distribution. The distribution just means how are these scores distributed across the possible scores that were received, okay? So on a negatively skewed distribution, the mean is less than the median. The average score is going to be lower than the middle score, and the tail is on the left. If the tail is on the left, the tail tells the tail, meaning that it's going to be negatively distributed. Okay, so for example, most students got high scores, but a few really low ones dragged the average down. Because those low scores dragged the average down, the mean score is going to be lower than the median score. Okay. And the positively skewed distributions are just the opposite. The mean is going to be greater than the median. The tail is going to be on the right. So for example, most people finished the race quickly, but a few people took a really long time. If we were going to do race scores, right? Race scores are going to be positively skewed if there's some really fast people, but there's some that took a really long time. Okay. So remember earlier when I said the degree or the amount of skew is the mean minus the median. So if the mean of a distribution is 200 and the median score is 190, then the degree of skewedness is 10, because the mean 200 minus the median 190 is 10. Okay. And because 10 is a positive number, we have a positive skew. Did I lose anybody on that?
No.
Okay, you can see here on our curve, the mean score was 200. The median score is 190. To find the amount of skew, we're going to do mean minus median. So the mean is 200 minus the median of 190 means a skew of 10, and 10 is a positive number as opposed to negative 10. right? Because it's positive 10, then it's positively skewed.
Okay, yes.
All right, let's do another one with a negative skew. Remember, mean minus median equals skew. So if the mean of a distribution is 60 and the median score was 72, then the degree of skewedness is negative 12 because 60 minus 72 gives us a negative number, right? If we have 60 of something and we subtract 72, then our number is going to be below 0, which means it's a negative number. And that gives us a negative skew. Are you tracking?
Yes.
Okay, I don't want to lose anybody on this. So again, mean minus median equals skew. 60 minus 72 equals negative 12. That's a negative skew. 200 minus 190 gives us 10. That's a positive skew. Okay. All right, let's look at a few sample problems here. Which of the following distributions is more greatly skewed? Okay, we've got a mean of 70 and a median of 60, a mean of 75 and a median of 62, a mean of negative 65 and a median of negative 87, a mean of negative 82 and a median of negative 70.
D.
Okay. So when we're looking at the degree of skewedness, let's go ahead and just, so this one is actually C.
I was
See,
thinking C.
Okay. And so when you're looking at the degree of skewedness, it doesn't matter whether the number is positive or negative, right? Select the largest number because it indicates the greatest amount of skew. Okay, so let's just look at each one of these. 70, a mean of 70, median of 60. If we're subtracting, right, mean minus the median, mean is 70 minus the median, we've got a range of 10. 75 minus 62 gives us a range of 13. I know when we're subtracting negatives, it gets complicated, but basically, if we were to plot these on a number line, we'd see that there's a range of 22. Okay, which is negative 22 is what it would be. Negative 82 minus negative 70 gives us a range of 12. Okay, so the greatest skew here is C, negative 22.
Hmm. Josh, would that
Mm.
be on a question? Because I see how you got C. I saw it as because they were. I knew because I know that if you have the I can't think of it, the negative it because as long as it's between the negative and the negative one and positive one, which in this case it would be. I always thought it was the middle, but I never saw it where you calculated. But we wouldn't. I don't think we would have to calculate like this on a test, do we?
No, you're not going to have to
Okay.
calculate this.
Like I got confused for a minute. Like I don't.
So, so let's suppose all that you were given was the degree of skewedness, 10, 13, negative 22, and negative 12. Okay. That's the degree of skew. And you were asked which one is most greatly skewed. Negative 22 is more greatly skewed than 10, even though 10 is a positive number. It's which one is furthest away from 0, right? Negative 22 is further away from 0 than positive 10 is. And
Oh
so,
yeah, I got how I
yeah,
understood
yeah,
exactly what you were saying because I
right.
know that it doesn't matter if it's negative or not. But I was just saying like if this would not be like I've never seen it calculated this way.
Yeah,
And
you're not going to have to do difficult calculations on the test. maybe I could have designed this particular question better to make it a little bit more simple. But the idea is to know that mean minus the median equals the degree of skew. And then if we're looking at several degrees of skewedness to figure out which one is most greatly skewed, we have to look at which number is furthest from zero. And negative 22 is further from zero in the negative direction than 10 is in the positive direction. Okay, let's do another one. So what type of distribution do the following numbers represent? 11, 37, 23, 2, 37, 18, 4, and 12. Okay, what's it asking us to do? Let's think first about the question. What is the question asking us to do?
How the numbers are aligned?
Mhm. Right, we're going to have to take these numbers and put them in order, right? Because can we answer if it's a normal distribution, positively, negatively, inverted distribution? Can we answer those questions if we don't know the mean and the median?
No.
No.
No. So that's what we have to do first, right? So first we would have to calculate the mean or the average. Then we would have to calculate the median or the midpoint, and then we can determine the answer, okay? So if we're calculating the mean or the average, we'd add up all of these numbers, and that gives us 144. And then we divide by the number of numbers, which is 9, right? There's 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. And once we've done that, we get 16 as the mean. And then we need to calculate the median, which means we have to order the numbers. So we put them all in order. 2 is the lowest number, 37 is the highest number. And then we're going to find the middle number by dividing the total numbers by 2. That gives us 4.5. And so the middle number right at 4.5 would be 12. So the median or midpoint is 12. And then we can determine the answer, right? If the mean and the median are the same, then we have a normal distribution. Do we have a normal distribution?
No.
No, our mean is 16 and our median is 12. If the mean is smaller than the median, then we have a negatively skewed distribution. If the mean is larger or bigger than the median, then we have a positively skewed distribution. Okay, so the mean, 16, is higher than the median of 12. Therefore, these numbers represent a positive skew or a positively skewed distribution. You see how we arrived at that?
Yeah.
Questions? We're going to do another one here in just a second, but before we move to that one, is anybody just completely lost? I need me to go over that one again? Okay.
Thank
Yeah,
you.
Nicole, I will share the slides and the recording. You can go to the event, the Facebook event, and look for the link to those once I have it uploaded. Okay. Okay, so let's do another one that's similar. Okay, what type of distribution do the following numbers represent? Then we have our data set. Okay, is it normal, positively skewed, negatively skewed, or an inverted distribution? An inverted distribution, by the way, we didn't cover this, is instead of it being a bell shape like this, it's a U shape. That's not a very good U. That's more like a V, but it's like this, which means the highest scores are on the extremes and the lowest scores in the middle. But that's what an inverted distribution is. Okay, so let's look at our process again. So we need to calculate the mean, we need to calculate the median, and then we can determine the answer. Okay, so can anybody calculate the mean here before I pull the slide up? What's the mean of this data set?
X.
A little bit of math.
6.
6. And how did you get that, Lorraine?
Added all the numbers and divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 9.
Yeah. So when you add all the numbers up, you get
54,
54.
and you divide it by 6. I'm sorry,
50.
divided by 9, and you
Good.
get 6.
Good. That's exactly what you did, and that's exactly correct. Okay. So the mean is 6. Now we need to find out what the median is. And so how are we going to find the median? Has anybody done this already?
I'm working on it.
Good.
It's
7.
7.
Okay. Good. The median is 7. That's the midpoint. Okay. And so based on that, we need to determine the answer. If the mean is exactly the same as the median, we have a normal distribution. Do we have a normal distribution?
No.
No. What do we have?
Negative.
If it's a negative, if the mean
Right.
is lower.
Yes. Because the mean is less than the median, the numbers are negatively skewed. Awesome. Okay.
Can you repeat one more time what you stated the inverted distribution was?
Yeah, in an inverted distribution, our bell has flipped upside down. Okay. So on a normal distribution, a bell curve, the median score, that the mean, the median, and the mode is going to be the same, which is right in the middle. Okay. But on an inverted distribution, if that bell curve is flipped upside down, then on the extreme ends, that's when we have the highest scores, right? It's flipped upside down. I'm trying to think of a situation where you would have scores like that. Something would have to go really wonky with your test. So let's use the race analogy. Okay, race scores. Like, what was your racing time? So suppose 100 racers all got started, and after a bunch of the racers got past a checkpoint, there was a landslide and it covered the track. And all of the other racers got really, really poor times. So we have a lot that scored really, really well, and then a lot that scored really, really poorly, right? Our data set would be inverted like a U with high scores and then low scores and then not many in the middle. I wouldn't worry too much about
Thank you.
distributions. Yeah. I'm thinking of another example here of an inverted distribution. Suppose a teacher was giving a test and he taught most of the content on senior skip day. And so half of the class didn't get a lot of the content. And then the next day they took the test. And so you've got a lot of people that were there for senior skip day that scored really, really well. And then a lot of students that missed and they scored really, really poorly because they missed all of that content. That would be an inverted distribution, probably.
Even though I never seen one in my life, but I get it.
Yeah.
I don't think
It's
they're
just
gonna say it,
inverted is just upside down.
but that's exactly how I took it.
Yeah, good. Okay. Any other questions like that? That's all that I mean, skewed distributions do